Hello and welcome back. In the last video we were talking about users and groups and modifications of permissions and things like that, right? So we haven't really gone deep, but in this video I want to go deeper so that you get a full picture of how the entire permissions things work in Linux. So I'm gonna remove this. You do understand by now that this permission things is split into three. So we have read, write, execute, and read-execute. But we'll go into more details with that. First of all, let's do an ls on where we are, and let's create a file, and let's call it permissions demo. And by default, one thing you're going to notice about this new file is, first of all, it's a file, and we can tell by seeing the minus sign over there, and we have read, write, and dash for the user, because the first three items here is for the user, and in this case it's Dari, right? Because Dari created this file and these permissions are specific to the owner of the file. And because there is a dash here, meaning there is no execute, because there is read and write, that means I can't even run it as an executable. And what do we mean by executable? All the programs you see, so let's take an example of an executable. So which ls, because we've been executing this program all along. Okay, and let's do an ls on that. And if you notice that the user that owns this file or this program is root, and of course the dash tells us it's a file, so it's actually a file. It's just a file that contains instructions to run as a program. And so the owner has read, write, and execute on this file. And because the owner can do all of that, and what makes it an executable is just the fact that I can just type ls, or what if I just did usr bin ls, and this is basically just calling the program in its absolute path, because there's difference between absolute and relative path. So this is absolute path right here, because I'm calling all the folders that leads to where it's located. And if I did that, you can see it's actually done the same thing if I were to do that. Of course, there's a slight difference because one has some colors and the other doesn't, and that's a completely different thing entirely, which I don't want to go into so as not to confuse you. But the most important thing you want to take note of is the fact that both command is bringing back the same data. What if I did the same thing on permissions underscore demo? Let's try that. Permissions. If you notice, the error message says command not found, but does permission of this underscore demo actually exist? Of course it does, but because it's not an executable, we cannot execute it. The interpreter doesn't consider it as a command, and that's why the error is there. And so back to our discussions regarding the permissions on this file. We have read and write. It is not an executable, and so it cannot be executed. How about the next one? It also has read, write, and dash, the same thing, and that is for groups. So the one in the middle is for groups. Now the last one is for others, meaning others can only read this file, and others could be any other that is not the user or the group. So if there are other users in the system that doesn't belong to a group and is not the user who created the file, those are considered as others. Now let's start to play around with the different ways in which we can alter the permissions of this file. Now that's going to bring us to introducing a new command called chmod. Some people call it chmod, but it basically means change mode. So we want to change the mode of this file. And who do I want to change? I want to change the user. I want to add the user to just read. Basically, change mode for users to be able to read is the plus. The plus essentially adds that permission. And what do we want to run this operation on? the permissions demo. Let's clear the screen and do an ls. That didn't do anything. Why? Because that permission is there already. How about if we wanted to remove the right? All we need to do is just do -w, and if we do an ls, sure enough, you can see permissions underscore demo now has just to read for the user. How about if we want to make it executable by the user? Well, what we need to do now is to add x to permissions demo, and if we do an ls on that, as you can see, the color has changed and we now have read, no write, and execute for Dare. So this is how to change permissions on a file, and you can essentially do the same thing for group and others. So let's say, for example, we want to change permissions for the group to be able to read, to execute, and sure enough, permissions underscore demo now has read, write, execute for the group. And for others, let's add the execute for others as well. O represents others, and of course you can see that the others now have read and execute. One thing I'd like you to do is to take a moment, sit back and think for a moment. Does that mean if I have to make changes to all the user and group and others at the same time, I have to keep running these commands individually? Well, in Linux there is a way in which we can do that, rather than going back and forth doing u plus x or o plus g minus r or any of that. We can actually do it in one command. But before I show you, I need you to understand a few concepts. As you already know, permissions can be assigned to user, group, or others, represented by u, g, and o. Now the next thing I've written here is permissions can be off, read, write, execute, or no permissions at all. So you already know we've seen read, write, and execute, but each of these are represented by numbers. So read represents number 4, write represents number 2, execute represents number 1, and no permissions at all represents 0. And one very smart thing that gets done on Linux is the fact that we can combine these permissions into one. So if I added read plus write plus execute together, it will give us 7. And if you do read, which is number 4, plus write, which is number 2, plus execute, which is number 1, 4, 2, 1 gives us 7, and that's why the number 7 right here. And what if we did read plus write, which is 4 plus 2, that's number 6. How about if we did read plus execute, which is number 5, to give us 4 for read and 1 for execute. And the last one here, which is write plus execute, number 3. So you can pretty much combine as you like. It's just adding these numbers together to form however you want to write the permissions. So going back to our chmod command, if I did chmod 732 on some file, let's actually try that and see what happens. And we would have chmod 732. So 7, which represents the user, is read, write, execute. Number 3 is write and execute, and number 2 is write. Let's see what number 2 is. Number 2 is write, yes. So that works. And so whenever you see things like this, chmod 733, 777, 751, this is basically what's going on. So it's just combining these permissions and being able to represent it for user, group, or others. Well, I guess this is enough information to get you thinking about everything we've been doing and just allow it to assimilate and get you to enjoy everything about Linux right now. We still have quite more work to do, but For now, I'll leave you to just wrap your head around everything we've been doing and do a bit of practice on your own. So I hope this has been very informative for you, and in the next video we'll talk a bit more about users and permissions. See you in the next video.